Okay, so I'm going to go through the second problem on the practice quiz. So it says a car is traveling at 15 meters per second north at t equals 0. It completes a U-turn and is traveling at 15 meters per second south at t equals 10 seconds. What is its average acceleration? So the thing with the two t's, this is essentially saying you start a stopwatch and then you end it. And when it starts, it says 0, and when it ends, it says 10. That means that our time for this thing is going to be 10 seconds. Okay, and I'm going to start off with a picture here. So here's my car. It starts off going north, right? And then it's going to do a U-turn and end up going south. For a problem like this, we need to have a direction that we're going to call positive. I'm just going to call north positive. So I'll say that this is the positive direction. So anything pointed north, I'll call positive. Anything pointed south, I'll call negative. All right. Then I'm going to write down what I know. So, or actually, what am I looking for? It's asking for what is its average acceleration, so I'm looking for A. Then I'll write down what I know. Traveling at 15 meters per second north at t equals 0. So that means when I start the problem, when I start the stopwatch, it's going 15 meters per second north. So that's a velocity. I know it's a velocity because it's in meters per second. Meters per second is the unit for velocity. So VI equals 15. Okay, what else do I know? At the end of the problem, it completes a U-turn. Is going 15 meters per second south at t equals 10 seconds. So that's at the end, it's going 15 meters per second, but it's going that way. I'm going to call that negative 15 because it's in the opposite direction as my positive direction. So that's plus, this would be minus here. So VF, our final velocity is going to be negative 15. All right. That should be all I need to solve the problem. I just know time, initial velocity, final velocity, and acceleration. Or I'm looking for acceleration. Now I'm looking for one of these formulas that ties these things together. So something that just has VI, VF, T, and A. The second equation does that, so I'll use that. So VF is equal to VI plus AT. Then I'll plug in my numbers for what I know. So I'll replace VF with negative 15. I'll replace VI with 15 plus A times, and our time is 10. Okay, so then I'm solving this for A, which means basically get A by itself. I've got a 15 on the same side as A, so I'm going to get rid of this 15 here. So I want to isolate A on one side of the equal sign. This is the side that has A on it. I'm getting rid of anything that's not A on that side. So I'll get rid of the 15 first. By subtracting 15 from both sides, I get negative 30 is equal to A times 10. Then I've got A multiplied by 10. The way I undo multiplication is division, so I'm going to divide both sides by 10. I end up with negative 3 is equal to A. I got to put my units here, so it's going to be negative 3 meters per second squared is equal to A. It's going to be negative 3 meters per second squared because it's going to be pointing in that direction. So its acceleration is that way during this problem. That makes sense because if you think about like this motion with something in the air, our acceleration is always pointed down, and this is what it looks like if you throw something in the air. But the car itself is accelerating south the whole time. So I can either leave it as negative 3 meters per second squared, or I could say 3 meters per second squared south equals A. Either of those are proper answers for that.